Hello everyone in the Future channel. We will resume our headway calculation. How can we calculate headway for 4-aspect signal? How can we calculate the 4-aspect headway? As illustrated here in the diagram, the 4-aspect arrangement. The first aspect is a preceded aspect. The second one is the first quotient signal. The third one is the second quotient signal. And the fourth one is the exit signal from the block section, and the distance between the entrance signal and the exit signal is B. We have our formula here, H equals S plus O plus L plus B, where H is the headway in meters, S is sighting distance, it's assumed 8 to 10 seconds, O is overlap in meters, L is a train length in meters, P is the distance between entrance and exit signal, which equal 1.5 multiplied by SPD, service braking distance. For example, a line is signaled for operation at 100 km per hour using 4-aspect signaling with regularly spaced signals with a signal spacing of 1054 meters. Each signal has an overlap of 180 meters. The signal sighting allowance to be used is 8 seconds. A fleet of multiple unit trains 160 meters in length are used on the line. What is the minimum headway? We have a multiple choices here. For our diagram illustrated here, the 4-aspect arrangement. So we have train number 2 and train number 1. If train number 2 gets a preceded aspect or preceded signal, which is a green aspect on the first signal, so train number 2 will enter the block section here, and at the second signal, which is a first quotient signal, has a double yellow aspect, means that the train driver will expect a yellow aspect in the next signal, so the train driver will start to decrease the train speed at the third signal when he has a yellow aspect here for at the second quotient signal. So this means the train driver will expect a stop signal at the exit signal for the block section. So the train driver will decelerate or decrease the speed to come stop at the front of the red aspect here. So the SPD or service braking distance is from the entrance signal to the third signal or second quotient signal here, or from the second quotient here or the first quotient signal to the red aspect here. So all this is the service braking distance. So all this, the distance between two signals here, is SPD divided by 2, SPD divided by 2, and SPD here divided by 2 as well. Then for aspect signal, we have a formula H equal S plus P plus O plus L. V is the train speed equal D distance divided by time, meters per second. V here is 100 km per hour, so we have to convert it to meter per second, so it equal 27.78 meter per second. O is the overlap 180 meter. L is the train length is 160 meter. S is the sighting distance, will be 8 seconds here multiplied by the train speed V, which equal 222.22 meters. P is the distance between the entrance signal and the exit signal. This is B. So B here is equal 1.5 multiplied by SPD, because we have here SVD divided by 2, SVD divided by 2, SVD divided by 2. So B here will equal 3 by 2 SVD, or 3 divided by 2 SVD. So 1.5 multiplied by 2 multiplied by the distance between two signals here, which 1054 meters. So we'll get 3162 meters. So H, or the headway distance, it will be 3724.22 meters. If we need to get the headway in a second or in a time, so we can divide this distance by the train speed, this one, so we'll get 134 seconds. So our choice will be number A. What does it mean of pooling point? What does it mean of clearance point? Let's figure it out in the upcoming video. Thank you.